So we are the Harvard Undergraduate Robotics Club, and under that, the Mars Rover team. And we're making a Mars Rover to compete in Utah for the University Rover Challenge. Right now, we have our arm complete and our suspension on the way in a temporary wooden chassis, but there will be changes and a lot of additions before next summer. We can start with the arm, which should have enough dexterity to pick up a small USB and place it on a lander or control a joystick as well, or even type. At the same time, it should be able to carry something really heavy. So 5 kilograms, and it could be a big rock, it could be a toolbox. So different objects, different shapes, different weights. In terms of software, there's a lot of autonomous navigation. So knowing, okay, AR tag detection, should we make a turn here? Should we go this way? Which way? In terms of the science team, we have to make a life detecting experiment. So we drill into the dirt and sample the dirt to see if there's life on Mars, but really the Utah desert. Yeah, and electrical just, what would we do without electrical? They power everything.
So we have a guitar here that Kang is showing off. We have mechanical keyboard switches in the frets and the strum bar. This is an upgrade from the standard model that uses silicone membrane, so this is a more precise guitar. There's a digital tilt sensor, so Kang just activated star power by holding the guitar up. When he reaches the sustain note, he can whammy the notes with the potentiometer on the front that'll oscillate the sound to it. A lot of these guitars haven't been made in a long time, so it's important to be able to make custom replacement parts for all of them. And we're all musicians and like to play these games.
So what we have today is an archery training aid. This green part is a handle of a recurve bow, and our device here helps archers identify if they have bad habits and also work on their stability muscles as a training aid. So we have two different forms of feedback. The first is a graphical user face, GUI, on the screen here, where the green dot tracks the motion of the bow's handle. And as Mike gets shaky, you see the green dot kind of going all over the bullseye. And as he stabilizes, the green dot centers on the center. And then on the bottom of the GUI, you see here there's a white dot that indicates how the bow is tilted. You want to maintain a vertical orientation of the bow, and so that helps identify whether you're canting the bow one way or the other. We also have a LiDAR sensor off the front of the bow, and that's measuring distance to the target, which is read out at the bottom of the GUI screen and also at the back of the bow handle on an OLED screen here. So the practical use of this is a training aid where archers could, load weight on this and practice their stability, try to keep that dot on the center of the target. It also gives useful metrics like distance to the target that helps with aiming and identify if archers have bad habits, like maybe they're flinching right before they shoot the arrow.
So this is Lift Assist, and it's a device that helps weightlifters track their form, track their reps, and this one's specifically for squats. So it'll help you tell if your bar path is stable or if you're kind of moving all over the place, and it'll also track if you're going low enough to hit your squat. So we were inspired to make this project because me and Cody, my partner, we actually became friends because we used to go to the gym together a lot. We're both really into powerlifting, and I recently went to a powerlifting competition, and the thing about powerlifting competitions is that you have to perform in front without using a mirror. So you really have to know your form without being able to see yourself. So that's how we came up with this idea of a sensor-powered way of measuring how well you're doing with your form. Basically, the way that it works is you would clamp this on to the end of your barbell, and then you have a display here that essentially tells you how many reps you're doing, if you're keeping stable, or if you're doing, or if you need to straighten yourself out, and if you need to be going low enough.
So the Finesse Glove is a glove that controls the direction of this inflatable shark, and the way it works is it's an infrared. There's an infrared sensor on the shark, and so this circuit sends infrared signals to the shark, and then tells it what direction it moves in.
So we just wanted something that was kind of sci-fi, very sci-fi. Since it's an ES50 final project, we wanted something very cool, and we thought, oh, what's cooler than a flying shark that we can control with our hand?
Hi, welcome to the musical, which is a muscle-activated boom whacker adaptive instrument. So I'll pass it to Peyton.
And so basically, we're actively looking at the EMG signals coming out of each of these three participants they have two EMG electrode monitors attached to each of them. And so we have the active electrode, which is actively collecting the muscle activity, and then the two other electrodes, which are the differentiating electrode and the control electrode. So basically our motivation for creating this instrument was for students with different muscular disabilities. And in elementary school classes and things like that, it's difficult for people that don't have full range of motion to engage in similar musical instruments. And this is one way that you're able to have everyone engage because you're able to fix the thresholds to exactly the muscular level of the individual person, which makes it very accessible to everyone. We also think this could act as some sort of physical therapy tool because as you get stronger, you can increase the muscular thresholds and continue to build your muscle strength. So we really think there's a lot of applications for this.
So this is our project. We made a digital tic-tac-toe console. And so the way it works is that there was this grid of buttons and it would correspond to each one of these NeoPixel grids. And depending on whose turn it would light up with X or O, as seen on the video. Unfortunately, last night we fried all of the NeoPixels at once. Not entirely sure how that happened. We probably sent too much power at once. So fortunately, the button detection circuit still works. So as we hit, it displays which button is pressed. And as a substitute for a game, we mocked this up very quickly so that every pin can display like like an X or an O based on a different color. And then, friends can play together.